Sound working? Sound is working. All right. Hello, Rice. Hello, folks. How are we doing? It's funny that the whole channel has gone so quiet and just it's like the calm of the season, isn't it? All right. I haven't actually checked my email in like a couple of days. It's been a bit busy. But let's try and work through some questions for what do we got? What do we got? Level 3 integration kinematics question. So we do that one first. Fair enough, Weedy. I can't remember, Rice. We just do whichever one we want to do, like whatever questions, because I don't think we're gonna have like a theme or anything like that. Like this question was popped up, but like I feel like I've done this question before. But let me just paste it, and then we can actually go from there. Rice, if you have sent it, just feel free to send it again, and we'll just work through the questions today. A trig function integration. Sure, we can do one of those, Stacy. Have you got a question with you by any chance? Chunky Max, I actually did a question that was very similar to the exam in a tutorial 2 years ago when I was just playing around with some questions. Somebody alerted me and they were like, oh, there was a question exactly like the one you'd done in one of the live stream tutorials before. On my website, Ananya. I'm thinking it might be, are you talking about my email or website? Because I don't know which email that is. How long does this thing need to take to sync? Come on. Sync this notebook now. There we go. Yeah, sure. We can have a look at that, Stacy. Like this was the question I got sent. I get a feeling that I've done this question before, but I don't mind doing it again if you want me to go through it again. Thank you, Jacob. I mean, I appreciate it, but honestly, I am so good. Like, you should have got that coffee yourself. Oh man, what are you guys doing? Thank you, Marco. Nah, seriously, guys. Like, please don't worry about the supers. Like, don't worry about any donations. Like, look, let's just get on with the work. Jason, differentiation question 3E. Look, let me put an order because I'm going to do some questions today. So we'll do this one first. Someone remind me. I think question 2, we're going to do some trig integration. And then question 3, we can do 2016 3E. I don't know what. I think I've done it before, but I can't remember. All right, so question E here. The integration one. Do we want to give you guys a couple of minutes to give it a go first, and then I could actually go through the answers? Or do you just want me to start going through the questions straight away? So Mesh, it's entirely up to you. My kind of recommendation for doing 3 papers is that try and focus on the questions that you know how to do first. So I don't really do like I kind of go through it. I read through the paper, and then I try and do the questions that I know first. Like if I see a proof question, especially in complex numbers, I try and do those first. I give myself like a 10-minute window to try and do that question, because if I get the proof question, then I know I've got the answer correct, which means I'm going to guarantee myself some excellence grades. And So I wouldn't bother with like the merit or achieved questions. So you cut your time out a little bit. Oh, crazy, Marco. You're crazy, mate. Honestly. So yeah, so Somesh, it really depends on your strengths. Like, don't do things that you find hard first, because then what you tend to do is like you end up wasting a bit of time, and then you lose a bit of confidence in the exam as well. So really important is read through all the questions and then attempt the questions that you know first, so that you feel that you feel confident with both your time and so you feel confident with the time and thingy, like what do you call it, and knowing that you can actually do a few of these things. Integration 2022 1D and others like that. Cormac, I can't remember integration 2022. Stacy, I think the differentiation question is 3. Oh, look, Preet, like that's a really quick kind of question. I know that it's I think like someone sent me that before. All it is just, it just looks like this, and then y is equal to 2x plus 6 over 3, and then that's it. So that's your question. Alice, yeah, we could, like, look, Alice, we could do a post debrief. I don't know when, but I saw that the questions were actually out. So I saw the level 2 questions were out, but the level 1 questions, they might be out tomorrow. So maybe we can either do it tomorrow or even later than this, because I was going to spend a bit of time with the level 3s today, because I've kind of been ignoring them for the last 3 days. So okay, so we're going to start doing this question here, folks, because I just want to kind of move on and try and do as many questions as possible today. So we are going to integrate this with 20 ln of t over t. Now, to do this particular question, what I would say is, yes, Scoot, I'm doing one on Sunday night. I'm just checking whether we might be able to do a Saturday night one. It depends on a couple of things, like because it depends if I'm actually at home and my wife's gonna go away with her mates. If she does, then I'll run a stream. If not, yeah, I probably won't. Yeah, Marco, like this, the level 2 papers are already out for from yesterday's exam. They're already out on the NZQA website. Hand grenade, give me like till the 14th of November. 14th of November is next week, right? Yep, it's next week. I am going to genuinely look at this body pillow thing, all right? I'm not kidding you. I'm looking at some, maybe bringing some in and slapping my logo on top of that and trying to figure out how I do that. So that's my next kind of job, okay? So there's a few bit of merchandise that I need to work on the 14th of November onwards. All right, so with this, what we're going to do is velocity is equal to integral of this. Now, remember I talked to you guys about this before. Like, if you ever see something like as ugly as this, then what I would suggest to you is use substitution. So what we're going to do is we're going to put down u is equal to ln of t. And then if u equals ln of t, then du over dt equals 1 over t. And then I could say that du is equal to 1 over t times dt. So what I'm going to do is I'm going to go back to this velocity function, and I'm going to separate things at the moment. I'm going to rewrite this as 20 multiplied by ln of t multiplied by 1 over t dt. And the reason I'm actually doing this is because I can replace ln of t with u, and I can replace 1 over t dt as du. So if that's the case, I'm going to get velocity is equal to 20 u du, because I've already proven all of that by substitution. So Stacy, like, what's a good way to kind of figure out? And I think, like, look, with U substitution, what's really important is that you've got to. It's usually the ugly things that you want to get rid of, right? Like, say for example, you have something like square root of x squared plus 3, something like this. Then what you generally would do is put this entire thing as u. So it's like whatever the most craziest looking thing, you would put that as u, and then you should be able to get du from that. Now let's go back to this one here. So we've actually got velocity is equal to 20 u squared over 2 plus c, or velocity is equal to 10 u squared plus c. Now because we know that u is equal to ln of t, we can show that v is equal to 10 ln of t squared plus c. Pretty much that is the acceleration, but I'm actually integrating it to get to the velocity. Stacy, if you have sine and cos, you might actually have to do, it might look like this. If it does look like that, I think you can choose either, and you should be like, if I have something like this, sine 2x, I'm sorry, just give me 1 second, just trying to write this. Would that work? 2 sine x cos x sine squared x over 2. Yeah, so something like this, you could potentially use either for we'll actually do that one next, all right? So I can show you how it actually works out. But I think I might have made up that question, and I might have actually made a mistake with it. But anyway, look, what other information do we have? We actually have this information here. The object was moving at a velocity of 12 when t is equal to 4. So t is equal to 4, v is equal to 12. So we're going to get 12 is equal to 10 times ln of 4 squared plus c, and so we're going to get c is equal to 12 minus 10 ln of 4 squared. Now whatever that c is, I'm just going to put that in the calculator. 12 take away 10 times ln of 4 squared. So that's going to give me negative we got negative 7.28, 218 actually. So velocity is equal to 10 ln of t squared minus 7.218. Now the question is actually asking find the velocity after 10 seconds. So t is equal to 10, velocity is equal to 10 ln of 10 squared minus 7.218. So we're going to put that in the calculator. So we've got 10 times ln of 10 squared minus, I'm just going to go plus the answer because I already got that minus in there. So I've got 45.8 meters per second. Now, Alice, I think what you'll find is that as you, like, I know it looks complex right now. If you think about it, tables, equations, and graphs would have looked very complex at the beginning when you feel like a year 7 or something like that. PSV, we talked about that yesterday with the KE. All right, folks, so how did we, any questions with this one so far? Let me put up a couple of line numbers just to see if there's any issues. Alian, I'm just mixing it all up. So if you have any questions, chuck the question and answer up on my email, and I'm happy to actually go through it. Sophie, I don't think I thought you guys already finished level 3 probability. I haven't actually had a look at the paper at all. ADAC, we're going to be doing definitely one on Sunday. I haven't, Sophia, I'm sorry. I like, honestly, I how do I say it? Like I said to you, like I only started doing these papers about, 3 weeks ago. So in my head, I haven't even prepared myself to do these extra papers. So maybe. F. You can, but I think it requires. I mean, you got to be fairly confident with doing. Like, sometimes I can look at a question and go, because I've done so many of these questions over so many years. Like, I wouldn't have even used substitution for this because I know that integrate, like differentiation of ln of t is 1 over t. So I would have straight up gone 20 ln of t squared over 2 because I know that they are connected. Yeah, Alian, I've got my email address at the bottom of just below the calculator. You can just, or even in the description, you can always just flick it over. All right, let's have a look, Rice. We're gonna go through your question next. Oh, that question. K sine squared x. Okay, actually this question might be connected to both. I don't know how well we can read this, but I'll try and get as much of a quality as I can. Wait, Rice, why are you having problems with this question? Because this is just Simpsons rule, right? Like, this is just one of those annoying questions. Like, let me just, give me a second. Let me grab the formula sheet. Yeah, I think I responded to you, Ish, and I think I might have responded to you somewhere. Now, look, this question here is just an annoying question, really, because all you have to do is it's saying that if we know use Simpsons rule, find the value of k. Oof. Rotate by the x from 0 to 3. Well, there's two ways to look at this here, Rice. We could actually use. I mean, I would have the way I would have done this. I would have just put this straight up. Like, I would have gone 12 units cubed is equal to integral of pi k sine squared x dx, and it's actually between 3 and 0. So I would have probably done with that. But then the issue with that is you can't actually integrate sine squared x, like you know how Stacy was asking before. All right, so I'm just gonna pause here for a second because I know that guys, the level 3's got like the their exams coming up in a couple of days, and it's pretty big for them. So if we could kind of like move along, I'll give you guys your level 1s later time, but can we keep the chat to level 3s please, because they do need this time right now, and some of them have got like unis grade university entrances at stake at the moment. So if we could just hold off on the chat, like don't get me wrong, I will come and have a separate level 1 kind of like debrief, but let's try and get rid of these questions for the level 3s because they're going to be stressed with their just their university stuff. So yep, Allianz Swedes. So I think Stacy, you kind of were asking me how do I do integral of trig functions, right? Now this is a great question to kind of show, because if I actually do 12 30 pi k squared sine 4x dx, now here's the problem, I can't actually integrate this because when I integrate this I'm going to be left over with cos x. So therefore we can't actually do this at all. It won't work like this. But instead what they're saying is use Simpsons rule with 6 sub intervals. Now if you're going to use Simpsons rule, we're going to use this rule, but we're going to have to create a table first. So we're going to create a table like this, where this is going to be x and y. So our first one is we've got 0, 0.5, 1, 1.5, 2, 2.5, and 3. And that's got 6 sub intervals. So I'm going to go 0, 0.5, 1, 1.5, 2, 2.5, and 3. Then what I've got to do is I've got to find out all the y values for that. Now at 1.5 it looks pretty obvious, but like because how do I say it, it's like k sine squared x, right? So because of that it's a bit of an annoying thing. So I would almost go at 0. Where's my calculator? Oh, sorry, I didn't realize ads were on. Sorry. So if I go sine 0, I am going to get 0. So that's fine. That's going to be 0 there. But then if I do sine of 0.5, I'm going to get this value here, 0.48. So this is going to be 0.48k. And then sine of 1 equals 0.84k. And I'm literally, what I'm doing is I'm creating this 0.99k. Sine of 2 is 0.91k. Please tell me my calculator is not in degrees. Oh yeah, that's fine. And then I've got sine of 2.5, 0.59k, and then sine of 3, now interestingly enough that should have been 0. Oh, have I stuffed this up? Oh god, yeah, you're right. Yep. So that's super annoying. Yeah, you guys are right. So I've got to actually now the sine 4x is for the volume itself. So if you look at it, that's the volume, but then the y value is what I need to put in here with the k there. So what I should have done is like sine 0 squared, and then I should have actually gone sine 1 squared actually. So not sine 1, sine 0.5 and then square of that is 0.23. So I've got to repeat the whole step again. No, I missed sine 1. Oh, God. Rice, this is a super annoying question, I have to say. Sine 1, and then square of that is 0.71. And then you've got sine 1.5. Square of that is equal to 0.99k. Now I'm just wondering, that 3 is not actually at 0, so that's okay. So, and then I've got to do sine 2 squared is 0.826 or 83k. Sorry, I'm just gonna be a bit lazy about this. 0.36k, and then finally sine 3 squared of that is 0.02k. So Rice, what you're gonna do is you're pretty much gonna put these as y0, y1, y2, y3, y4, y5, and y6. And then what we're gonna do is we're gonna actually put down, because we know the volume is equal to 12. That's not gonna work. Man, this is a nasty question. Okay, hang on. Let's just go back to the formula sheet. This is a double angle. Actually, you're right. Rice and Stacy, you guys are gonna love this question. I'm stuck. I need to think about this question. Sine 4x could be written as sine squared x squared. Z, you know, I've done the papers before, but I'm just looking at this question at the moment. Hey Rice, I'm actually gonna have to do this question separately, man, because this is like a very, very long question, because I would need to do, like, the way I'm seeing it is I've got to actually integrate sine to the power of 4x, but I would have to actually do this first. I would have to separate this first as sine squared x squared, but then because sine squared x, I would have to use the double angle formula here. So I would actually have to go cos 2x is equal to 1 minus 2 sine squared x, and then cos 2x minus 1 is equal to minus 2 sine squared x, and then sine squared x is equal to cos 2x minus 1 divided by negative 2. So this is going to be a brutal question, to be honest, because it's going to be like 1 over 2 minus cos 2x over 2. So integral is going to be a half minus cos 2x over 2 squared dx. And then I've got to expand that bracket to create another equation and then go from there. That's I can see why you're so frustrated with that question, Rice. But do you get what I'm trying to say there? It's just there's a lot happening in this question. Product to sum. No, we won't be able to do product. Okay, well, if you were to do that, sine squared x, I mean, it'll still come up to be the same, right? Because you'd have sine squared x. No, but that'll be, product is like one of them. Now you'd still end up with the same kind of horrible looking equation. Who was it that I wrote that? Aramant. You would still end up with that like a half times cos 2x squared. I mean, it'll work, but it just I need to actually sit through and do this long term. All right, OMP, good for you. That went well. So Rice, what I'll do is just send me a message again. I will maybe in the Saturday morning coffee. I'll sit and try and work through that. So going back to this, yeah, Yeti. I think the question was 2016 3E differentiation. Now look, if this question I've done before, I just want to double check. I haven't actually done this before because there's a very good chance I might have done this one before. 578, 2016. All good, Zala. It's been quite interesting. Good growth. Okay, so what do we got? We got level 3, 2016, question 3E. Is this a rugby post question? Please tell me it's not. What is the rugby post question? I'm sure I've done this question so many times, but like, look, I would prefer doing another question, whoever sent me this question, because I think I did it. I can tell you exactly which tutorial I did it in, because it just, what I don't want to do is like just spend time doing questions that we've done through before, especially if there were already tutorials on it. Just give me a second, I just want to have a look through this. Complex 2016. Because I remember doing this rugby question, that's why I'm like, here we go. The rugby question, I did it on 7th of November 2022. So I will find that video for you. So if you are stuck on that question, you can actually look at it. 7th of videos, playlist. Where would it be? When was it? 7th of November 2022. Okay, so here's the 7th of November. Oh, lovely. Thank you for this stupid ad. Rugby question. Here we go. So I'll share this one. So if you do want to have a look at the 2016 question for the rugby question, then you can actually watch it here. So we can actually pick another question. So 2016 rugby question is here. Okay, so let me just have a look, because what are the questions you folks have sent me? Alian, which question was this? So Alian, I know I did this question on, because I know you've sent me this question here, which is, sorry, give me a second, let me just go and load this up. Okay, the next question number 4, what is it? We have Alian, you asked me this question, 2021 question E. Again, 2021, that was last year, Alian. Just have a look at that video, because I've already done that question as well. That's in the 2021 video. Just have a look at it, let me know if you don't understand it, and then we can go from there, alright? Because yeah, it's just like we've done those kind of questions before. Next, Jason saying, I think Jason, you sent me the rugby question. I've just sent you I'll send you the link so you can watch it. Who's next? Next question. Easier to achieve excellence. Harman, just for your advice, I would say whichever one you find easier, really. So that's what I would kind of go with. Why is my email playing up? Come on, man, don't play up on this time. Shirley, I'm just having a look at your question right now. Yeah, that's a crazy question, Shirley, but I'll put it up here. I don't know if people want to try this one. This is like a really old question, but it is a differentiation question. Heavenly Dean, absolutely yes. Alvin, parametric equations, second differentiation is the most, like, all you have to do is just substitute in the equations, because you get the equations given to you in the formula sheet. You copy the formula sheet and you just do the differentiation, and you pretty much you're good to go. (2019) question. Mel, again, like, look, any of the later papers, folks, like I've already done videos for them, so have a look at it, and if you're still having problems, send me a message. Like, just say, hey, look, I don't understand how to do what you did in that 5th or 6th line, and go from there. Because I'm just aware of people that are here that kind of want to do questions that we haven't actually seen before. So if you like, hold off on any kind of from like 2017 up, because I think I've done all the way up to 2017. But anything before that, just feel free to flick it to me. Yeah. Sonia, are you talking about rates of change question? Because those are the ones that you would do that. Okay. So how would you start this one? Like if you think about it like this, right? This is a here is where the x and y axis is. So if you were to take this point right here, this point here could be known as x and y. Now the x distance is from here to here, and the y distance is the green line. So if you look at the rectangle inside, the base is going to be 2x and the height is going to be 2y. Daniel, yeah, they only had like 7 or 8 questions and it was like a half-an-hour paper, so they don't only have like 1 or 2 kind of questions in it. So Sonia, if you can find a rate of change questions pre-2015, we can try and do one of those, yeah? So here we have area is equal to 2x times 2y, and because we have x squared over 9 plus y squared is equal to 1, rearrange to get whatever y is and then substitute it in here, differentiate, put it equal to 0, find x, and then find the maximum area. So I'm going to give you guys about 5 minutes to try and do this question, and then I will actually go through it. All right, so you guys try, you folks try it first, and then we'll actually go from there. You're welcome, Joe Channel. Best advice for going to uni? Man, you shouldn't ask me. I failed uni 5 years before I got my act together. Well, it wasn't 5 actually. Hang on, let me think. No, it was 5. Damn, I failed 5 years before I got my act together. You probably shouldn't get any advice from me. If you have to double differentiate rates of change equations, nah. Well, rates of change equations, I don't think you'll need to double differentiate, because it'll be like, usually you'll only differentiate it once. You're welcome, Rubber Ducky. I gotta go around signing a few more calculators then, Nelson. I have no idea, CEO Master, but that looks like a great movie that you could potentially make. The heist of the century, right? Stealing NCA papers. Okay, so Stacey, after this one, I'll show you an example of double differentiation of parametrics, all right? Because if it does come, folks, it is a very nice question. Alice, look, I'm gonna be brutally honest. Like I think Daniel asked before, you know, what's the advice for uni? I failed university 5 years before I got my act together. Okay, so you know, level 1 it's okay. There's far more silly things that we can do out of school. Unfortunately, no, Daniel, I don't. Not sure, Kaisu. I've not seen it. I mean, I saw it in the earlier years, like, but not now. Why are you trying to integrate this, Bryce? Why? Now, Alu, look, I'm gonna be honest with you. The KE question I did yesterday, it was easy, and I looked at the algebra paper. Guys, I don't know what you guys are talking about. Like, it was such a good paper because the achieves were easy, the merits were easy, the excellence were. I promise you this: when I do the excellence questions, you're gonna be like, "Oh my God, that was it." That's what an exam paper is supposed to be like. It's supposed to make you think, but you do know how to do it, because I can tell you right now, I looked at all the excellence questions so far, and every one of them, I know that, you know, it's just that you need to think on the spot. That's the tricky part. But when I show you, you'll be like, I can't believe this was so easy. Nah, you wouldn't have, trust me, Alu, because I think I've seen your name pop up on some of the chats before. Okay, so let's actually start doing this question, all right? So we're going to rearrange y first. So when we rearrange y, we're going to get y squared equals 1 minus x squared over 9. Then y is equal to square root of 1 minus x squared over 9. Now I'm not going to worry about the plus or minus part. I'm just going to leave it as it is. So then area equals 2x times 2 times square root of 1 minus x squared over 9. So I'm going to get area is equal to 4x multiplied by 1 minus x squared over 9 to the power of half. Now, because I've got two things that are getting multiplied by each other, I am going to have to use product rule. So I'm going to get u is equal to 4x, u dash is equal to 4, v is equal to 1 minus x squared over 9 to the power of half, v dash is equal to half times 1 minus x squared over 9 to the power of negative half, multiplied by the differentiation of whatever's inside the bracket, which happens to be negative 2x over 9. So this simplifies to 1 minus x squared over 9 to the power of negative half, multiplied by negative x over 9. Okay, truly ugly looking thing here. But somehow we need to actually put this equal to 0 and actually kind of work it out. So what we're going to get is a dash is equal to u dash v plus uv dash. So we're going to get 4 times 1 minus x squared over 9 to the power of half plus u, which is 4x, times 1 minus x squared over 9 to the power of negative half, multiplied by negative x over 9. So what we're going to do now is, we know that maximum area is equal to 0, so we're going to put that as 0, and then we're going to rearrange this. So I'm going to bring let's see, what should I do? I'm going to bring this entire thing to the other side, which means I'm going to get minus 4x times negative x over 9 times 1 minus x squared over 9 to the power of negative half equals 4 times 1 minus x squared over 9 to the power of positive half. Hopefully you guys are with me with that line. Then I've got negative 4x squared over, no, positive 4x squared over 9 equals 4 times 1 minus x squared over 9 to the power of half divided by 1 minus x squared over 9 to the power of negative half. Now here is where things are going to get a little bit interesting, because that denominator is going to come to the numerator and they're going to become 1. So we're going to get 4x squared over 9 is equal to 4 times 1 minus x squared over 9. Now this is not looking good I am actually stuffing something up here. It's going to be minus 4x squared. No, actually, no, it's all right. We're going good so far. 4x squared over 9 is equal to, what am I going to get? 4 minus 4x squared over 9. Rearrange this. I'm going to get 8x squared over 9 is equal to 4. And then x squared equals 4 times 9 over 8. X squared equals 36 over 8. X squared is equal to 36 over 8. Whatever that is. Yeah, you're right. You're on the right track. We're on the right track. 36 divided by 8 is 4.5. So x is equal to square root of 4.5. Whatever that is. So if x equals to 2.12, then maximum area equals 4 times x times 1 minus x squared over 9 to the power of half. So I'm going to leave that x, I'm going to store it as a. Alpha a. And then I'm going to get 4 alpha a multiplied by 1 minus a squared divided by 9 to the power of 0.5. 6. There we go. A is equal to 6. Now, typical, this is not from a scholarship exam. This is just an old differentiation question. But it's actually a really good differentiation question because it's a little bit out there because but the thing is, you know, you can get asked this question because all you're doing is you're rearranging y equals to something and then differentiating it. Rice, in this case, we don't need to actually worry about some square root of something. Oh, right. Okay. So you're asking me that question, right? That's because like this. Think about it like this. If I have x to the power of positive 2 divided by x to the power of negative 2, then this could be, okay, wait, let me do another one first. Let me do this first just to show you. If I have x to the power of 7 divided by x squared, you would write this as x to the power of 7 minus 2, which equals to x to the power of 5. Now if I have x to the power of 7 divided by x to the power of negative 2, then you would do x to the power of 7, take away negative 2, which actually becomes plus, so therefore it becomes 9. So if I have x to the power of half divided by x to the power of negative half, I'm going to get x to the power of half minus negative half. Now half plus half equals x to the power of 1. Okay, I know this is a bit strange, but I'm looking at that name with the Hasvita, did you do probability as well? I gotta ask, because like I remember seeing this name somewhere. Sorry, Stacy, was that a yes, I got it, or did you have a question there? Oh, you did, okay. Oh, it's crack up, because I was like, oh, that's such a, like, sometimes you remember crazy, like different crazy bits of information that goes through your head. The probability one, I haven't actually had a look at it, but I think I might have seen it on Instagram or TikTok, I can't remember. Something popped up with your name on it. Can you do parametric equation I sent you? Yes, Zed. Folks, do you have any questions with this one? If you don't, we can head over to the parametric questions. AKA, I think Ashwina, you sent me some questions. Can you tell me which years they are? Because I have seen those questions, but I don't mind doing it. But could you tell me which year they are from, please? The dome question. Oh, wow. Okay. Jeez. All right, let's do this parametric question here. Question 3, parametric. Okay, find the coordinates and determine the nature. Oh, beautiful. Hang on, this was question 3A, was it? Zed, the question you sent me, was that an excellence question? All right, I have a look at it, Scott. I never understand what like, you know, what's the big deal about a shout out, Blake. But Kafi Ashkir, good luck for your exams. Yeah, there you go. I don't know what that does to people. I honestly don't. Scholarship question. Jeez, that's a brutal. I guess that could be counted as a TET. Oh my god, it's got a TET. Cheating, Zed, cheating. You're putting me in scholarship question. Okay, so with this question, parametric ones. So if we're doing parametric, TET, oh god, that's going to be annoying, but it's all right. Let me just go grab the formula sheet first, and then we can go from there. Formula sheet level 3. Okay, so parametric fit equation function is right there. I will actually bring that in. Oh god, yeah, I know it's a I can tell that it's a scholarship question, but what I'm gonna do is I'm just gonna show it because I think this is gonna be quite a bit of work, and I know like a lot of folks are not doing ScholCal at the moment, but I'm looking at this question, it's just like, oh god, there's so much work to do in this. All right, so we've got our little parametric equation there, but like, look, I will do it up to a certain point, folks, because I know that some people just want to, I want to show the double differentiation more than anything else. So the first thing we're gonna have to do is, I think someone asked there first before, like for parametric equation, I've got to work out dx dt and dy dt. So if x is equal to 2t minus 3t cubed, then I can say that dx dt is equal to 2 minus 9t squared. Now that's a nice and straightforward one. Now the next thing is looking at y. Y is TET. I've got to use the product rule for this. If I use product rule, I've got to get u equals to t, v equals e of t, then u dash is equal to 1, v dash is equal to e of t. So dy dt is equal to u dash v plus uv dash. So you're going to get 1 times v, which is et, plus tet. Okay, so we figured out this. The next thing we have to do is dy dx. to figure out dy dx, we're going to put dy dt, which is et plus tet, multiplied by dt dx. Now dt dx is dx dt is 2 minus 9t squared. So we've got to put it upside down. So we're going to get 2 minus 9t squared. So we're going to get dy dx is equal to et plus tet divided by 2 minus 9t squared. So this right here is pretty much your first kind of like, for parametric, this is the first part that you do. Now, if you're going to do double differentiation of parametric, you have got to look at this particular formula here. Actually, wait, let me do it like this. You have to look at this formula. Now, we have actually figured out what dy dx is, which is what's going to go in there. But we have to differentiate with respect to t. So, if I look at dy dx, dy dx is e to the power of t plus tet divided by 2 minus 9t squared. Now this is super annoying because we've got to use a quotient rule, but we also have a product rule inside the quotient rule, which is like blimmin' annoying. Oh, definitely, Scott. I think this is already at a achieved level so far for dy dx. But I think if you figure out the second derivative, you're almost good to go for what do I call it? Well, like, look, let me actually do the stationary point first, right? Because let's do that before we differentiate it twice. So I know that for stationary point, dy dx is equal to 0. So I can say 0 is equal to e to the power of t plus t e to the power of t 2 minus 9t squared. So 2 minus 9t squared, get rid of that. So 0 equals e to the power of t plus tet. So we're going to put 0 is equal to e to the power of t multiplied by 1 plus t. With that in mind, you've got e to the power of t equals to 0 or 1 plus t equals to 0. So you should get t equals minus 1. But the quadratic doesn't matter. Now you don't need to worry about the quadratic at the bottom because the quadratic gets multiplied by 0 and it disappears. Because remember, when you have a fraction equals to 0, the only part you need to remember is making the numerator 0. Erimand, all I've done is product rule there, because remember with product rule you would differentiate the first term, multiply it with the second term, then differentiate the second term and multiply it with the first term. That's just product rule that I've done there. Yes, Zed, you don't need to worry about the denominator, because if I tell you the numerator, because any fraction you have, if any fraction equals to 0, that means numerator has to equal to 0. Now, if t equals negative 1, we can actually figure out what x is, because x equals to 2t minus 3t cubed, which is going to be 2 times negative 1 minus 3 times negative 1 cubed. So negative 2 plus 3, negative 1 plus 3, yep, equals 1. And then y is equal to tet. So y equals negative e to the power of negative 1. So my stationary point is 1, negative e, negative 1. I'm not really bothered about working it out. I'm just going to leave it like that. So the second differentiation. Now this is the part where things are going to get a little bit dicey, but just trust me on this. I know this is a bit more complex question than what we normally get in a paper. Sure, Daniel, like for example, like if I actually have like how do I say it, if I take a number like 5, that's not going to work. Hang on. Like if I do this, right? If something divided by 6 is equal to 0, we don't really care what the denominator is, because in this case the top numerator is going to equal to 0. So you could have like something divided by 3 minus x equals to 0, and as long as x doesn't equal to 3, then the square should equal to 0, because it's just the numerator. We just have to worry about the numerator equal to 0. We ignore the denominator completely. Because if you think about it the other way, you would actually do it like this: 0 times 6, because you know how you cross multiply? And if you cross multiply, whatever's in the numerator will become 0. So this question here, when I had ET plus TET divided by 2 minus 9t squared equals to 0, if I cross multiply this, I am going to get 0 multiplied by 2 minus 9t squared. Now that's actually equal to 0. So that's why I kind of completely ignore that step and just go directly to saying numerator is actually equal to 0. Hopefully that made sense there for you, Zed and Daniel. Zed, are you happy with that now as to why the numerator is equal to 0? I'm going to get rid of this. Cool. So now comes the double differentiation part. Because the double differentiation part, what you have to do, and I'm not going to solve this, all right, because this is just, it's going to get very annoying. But so we've got dy dx, which is et minus tet divided by 2 minus 9t squared. So if I put this as u and v, u equals e to the power of t minus tet, v is 2 minus 9t squared, so v dash is equal to minus 18t. Now that one's easy. But as for the u dash, e of t, when you differentiate it, you're going to get e of t. But we already did tet, which we're going to use from right here. So when we had TET, that differentiated to ET plus TET. So if you have minus TET, this is going to become minus ET plus TET. So then U dash is equal to ET minus ET minus TET. So U dash is equal to negative TET. And we've got that. We've got that, right? But the problem is we're doing quotient rule. So d squared y over dx squared is equal to the differentiation of that, which is going to be u dash v minus uv dash divided by v squared, which is the quotient rule, multiplied by dt dx, which is 1 over 2 minus 9t squared. So that's the formula there. So as you can see, it is quite nasty looking equation, and that's why you do this in scholarship and not in normal paper. So I'm kind of going to stop there, guys, because I know we can literally keep going like this, and it's, but Zed, yeah, you can kind of finish it off at that point. Just substitute what is it, t equals to -1, and you should be able to get it to be either greater than 0 or less than 0, and then you should actually be able to do it. D3, it's always top minus bottom. Alright, so let's say you've got something like this, which is square root of x, and then let's say we have something like x squared, it is always the top minus bottom. Always. Alright, so I'm gonna skip from that question because that was like exceptionally long. I remember this question. Oh god. One rate of change question, and then we can I haven't seen it yet, Zed, because I picked up another question at the moment. Don't know why my emails are not refreshing. Jack, have a look at my papers already, my friend. I've already done those questions quite recently. I'm trying to do questions that we haven't actually done before. So, this one here, rate of change question. Oh, is it? All right, which question do you folks want to do? I've got a couple of questions here. One is that one, and the second one is this question here. Can do either, but I don't think I'll be able to do both because I'm falling asleep. So let me know which question we want to do today. All right, so we've got two questions popping up: the rectangular SOAP, or this optimization, or rate of change. I mean, I don't mind. I can do the other one later, but like pick one for today. Which one shall we do? You're welcome, EP. It's not a problem. SOAP. You guys suck. It's like I shouldn't have done that. Shouldn't have done that. Okay. You know what? Why not both? This is what you call exam season fatigue right now. It's kicking in. Okay, so we'll do the SOAP question first, and then we'll do the other one after that. Tell you what, we'll do the SOAP one first. I'll give you guys a couple of minutes. I'm just gonna go see if I can actually get a coffee, and then we'll do the next one after that. All right? Now I'm good. Look, your exams are gonna be done in 2-3 days. And then I've got a rest for, I go into hibernation for about 6 months. Nah, Daniel, I think I posted the YouTube question on the KE. Well, unless somebody else posted it. All right, coffee time. I'll be back in a couple of minutes. You guys try and do this question. Water. Oh, okay. Stuff it. Let's just do this. I can actually get some shut eye. Width. All right, so what do we got here? We've got, this is the shape of this soap here, twice as width, and it's dissolved at 2 centimeter cube per minute. So dV dt is -2. Yeah, I'm gonna put it as -2 centimeter cubed. The reason I'm putting -2 is because it's actually kind of dissolved in water, so it's actually reducing. Did you guys get that part of it? Then our volume is 2W times W times half W. So volume is equal to W cubed. That should be pretty straightforward. Next is the question's asking at what rate is the surface area decreasing when the volume of the soap is 50. Okay, so surface area is, we've got 2 front sides plus 2 how do I put it, front and back, top. I'm gonna color this, guys, sorry. So zone 1 is going to be yellow, zone 2 is the top, zone 3 is the sides. So you've got 2 of the plus 2 of this plus 2 of this. Because we're doing surface area, we'll have 2 of those sides in there. So surface area is 2 times the yellow part. Yellow is half W times 2W plus 2 times green part, which is going to be 2W times W, plus the 2 times blue part, which is going to be W times half W. Yes, I think you'll need to count the surface area of the soap bar. I think we'd have to count the bottom as well. So we're going to end up with 2W squared plus 4W squared plus W squared. So we should have 7W squared. Yes, Kalulesa will be doing it then. Okay, so the question's asking what is the surface area reducing when the volume of the soap is 50. So we're looking for dSA dt is, so what are all the things we've been given? Now this is the part where we kind of need to start doing a few things here, but let me do this first. I've got volume is equal to W cubed, so dV dW equals to 3W squared. I've got surface area here, respect to W is going to be 14W. So if I want to figure out what dSA dt is, I need to use this, and this, the favorite triple threat rate of change question, as I like to call it, you're going to end up with dSA dW multiplied by dW over dV multiplied by dV dt. Now, the reason why I put dV dW upside down is because I know that those two things are going to disappear and those two things are going to disappear, and what I'm left with is just dSA and dt. So substituting this, I'm going to get 14W multiplied by 1 over 3W squared multiplied by -2. So dSA dt is equal to -28 over 3W. Spare time, I would like to sleep. I bought FIFA 23 like, I don't know how long ago. I still haven't even played like I haven't even started a season on it yet. Sunday night, definitely, Stacy. Now, Stacy, if you put it as +2, right, as long as you mention at the end that the surface area is decreasing and you can put a negative, that's fine. So you could actually do that as well. But before we do this question, we actually need to know what W is when the slope is 50. So remember that W cubed equals to 50. So W equals 50 to the power of cube. And so dSA dt equals -28 over 3 times 50 to the power of a third. Whatever that is. So we've got -28 divided by 3 times cube root. Can I see a 3 cube root? I hope this is correct. It should have been -2.533 centimeters squared per second. Yeah, so Kaisu, just make sure you put that as negative because it is decreasing. So if you did get, you have to make sure that it's actually decreasing. No, it's 50 to the power of 1/3 Rice, because right at the beginning here, they actually say that what is it decreasing when it's 50 centimeter cubed. I don't know why, like it really sucks, but it's like my mouse doesn't, like the pointer, it doesn't actually show up on the what do you call it, this thing, and it sucks because it would be so easy to show it. Fireworks are over, man. Get over it. Jeez. So that was actually not a bad question, folks. Oh, is it per minute, is it? Yeah, per minute, sorry. I don't think we'll get penalized for that. That's just mean, but like, I don't know, just eat some food. All right, are we happy with that question? Gotta love Martin Graham. You know, he just puts the most randomest comment at the randomest time. Sumit, I'm actually from South India, Tamil Nadu. How far should you go back in the past papers? Stacy, like, I'm not gonna lie, like, you know, the calculus questions are like, they're pretty much, they rotate the questions at some point, so you can go as far as you want and you'll get all the different styles of questions, which is good. Especially the excellence ones have always been good ones to revise. They are, which is why I think we're gonna have to try and download all of them and keep them somewhere. I'm assuming you folks are okay with this, which means we can go to that sphere question next. Rice, eventually in the next few years. Not sure, Zed. Not sure. All right, let's go to this question here. Ignore the little triangle, but I'll get you folks to have a look at this first. Kevin, that was because the volume was 50 and we found the volume's equation was W cubed. So, to find W, you got to take the cube root of 50. So that's why it's 50 to the power of 1/3. Looking good. I think you probably want to be in radians for calculus. This sucks, man. Honestly, like, I think TikTok has picked up that I'm an educator, so all I get is like these bunch of kids wanting to do tutorials on the UK and the US, and that's all I get. It's like, how did you know that W equals to 50? Oh, sorry, I just didn't see that. It actually said it right there. The volume is 50, and then we found that V is equal to W cubed. And so see, we found V equals W cubed, volume was 50, and then that's what we did that. Sorry, I kind of have to go back to the question. No, not my stuff, Rice. It's like, I'm getting like other people's stuff. I get like this the Australians one and so on. I can try, Stacy, but I think this might be the last one because I gotta go get some shut eye because I still got school tomorrow. Okay, so best advice I give to people for these types of questions is this: whenever you see a 3D shape, change it into a 2-dimensional shape. All right, I cannot tell you any more than that. Now, looking at this particular question, because we've got somebody that's like kind of done it, but like what we can do is like this. We are gonna put a stupid semicircle. Like, is that a semisphere? Yeah, hemisphere. Okay, so what I'm gonna do is, I think the first thing I've got to work is the height. The height is what I gotta do first. What I know is if this is the center of the hemisphere. I don't know what I'm trying to say there. this distance from here to here is going to be 20. Do you guys agree with that? Because that's from like the middle to the edge, right? So that's going to be 20. This is a cylinder. Now from here to here it's going to be x. Then the height is going to be square root of 20 squared minus x squared. Pythagoras. Is that all right there? So if that's the case, 20 minus x squared, now we've got to actually work out the volume of the cylinder. Volume of the cylinder is going to be pi times pi r squared times h. Except in this case, we're going to get pi, instead of r, we're going to get x, which is x squared. And the height is equal to 20 squared minus x squared, which is 400 minus x squared. Does that look all right so far? Okay, let me just check. Let me do this. Curved surface area, cylinder, pi r squared h. Yeah, by the way, if you are stuck with that formula, it is given up here, which is the cylinder formula, which is pi r squared h. I kind of just use that. Pi r squared h is from the formula of cylinder, Aramant. So if you have a look here, right here, cylinder is pi r squared h. Nice, Zachary. You're welcome. So yeah, pretty much I think this is all you have to do, because now all you got to do is just differentiate and figure out what the maximum volume is. So we've got a product rule here. So pi x squared as one of them. This is our second equation. So u is equal to pi x squared, which means u dash is equal to 2 pi x. V is equal to 400 minus x squared to the power of half. V dash is equal to 400 minus x squared to the power of negative half. Half in the front times the differentiation of whatever's inside the bracket, which is minus 2x. So then V dash is equal to x times 400 minus x squared to the power of negative half. Okay, so that means we're going to get volume dashes u, oh damn it, I should have put volume, not V. So differentiation of volume is u dash v plus uv dash. U dash is 2 pi x multiplied by 400 minus x squared to the power of half, plus u, which equals to pi x squared, multiplied by v dash, which happens to be x, times 400 minus x squared to the power of negative half. Now people, this should be starting to make sense, because we remember we did this earlier today in this, something like this that pops up. So I'm going to get 2 pi x 400 minus x squared to the power of half plus pi x cubed 400 minus x squared, get out, to the power of negative half. This is volume dash is equal to 0. So, and then rearranging this, I'm going to get negative pi x cubed times 400 minus x squared to the power of negative half equals 2 pi x times 400 minus x squared to the power of half. Then I've got to divide this, so minus pi x cubed divided by 2 pi x equals 400 minus x squared to the power of positive half divided by 400 minus x squared to the power of negative half, and I'm gonna get negative x squared over 2 equals 400 minus x squared. Cross multiply, negative x squared equals 800 minus 2x squared. Rearrange, 2x squared minus x squared equals 800. I'm missing something. Oh no, I made a mistake somewhere, haven't I? No, I haven't. X squared equals 800. That looks good. That does not look good. Because the maximum... What have I made a mistake? I've made a mistake somewhere. Where have I made a mistake? Negative x. Where's negative x? Where did I miss it? Up top. Up top. Okay, wait. Let me just put some line numbers because I've made a mistake. I know I've made a mistake because I should not be getting this. Which line did I make a mistake in? Line 0. Oh man. Oh, that. Yep. I see it. Hey, there. So negative x. That's going to be negative x. That's going to be negative pi x3. Negative pi x3 means this will become plus. Okay, there we go. That's better. So x squared is equal to 800 over 3. X is equal to square root of 800 over 3. There we go, that's better. So x is equal to 16.33. I think it's asking for what are the dimensions of this. What are the dimensions of the cylinder? So that means cylinder's radius 16.33, and then height is equal to 400 minus Yeah, thank you. I think that's a good sign that I made a mistake with that. That one little mistake caused me that much grief. But I did know that I did something wrong, because when I did x squared as 800, I got an answer of 28.28, and I know that the maximum distance is 20. So I was like, oh no, I made a mistake somewhere. So thank you folks for picking that up. Yes, you're right. Definitely time for me to call it a day. 11.54. There you go. Adrian, are you actually at OSC? All right, I think 197 minutes of calculus, I think that's enough for one day. I know you're at OSC, Vadim. I think I should pop by on Monday morning before you guys do your calculus exam, just to give you some grief on the day. Not sure what that actually means, RX. I don't think it'll work cross-section area because cross-sectional area would not actually be max. Cross-sectional area max would be different than volume because volume is different to cross-sectional area. Let's see. You can always chill out and chat for a few minutes. It's always nice to chat. Give me a second. Let me just rearrange a few of the windows so that I can actually see people. What do we have? Where did I get up to? Adrian. Oh yeah, nah, that was I think at the middle of the year I came in to pick up a few things from the department because I stored some things there, some things that I could borrow. Have a good night, Rice. I'll see you later. Sumit, I think I might have to because my computer is starting to get a bit slow. Oh, Vader, you're just doing complex numbers. You're welcome, Johnny. Oh, you're welcome, guys. Johnny, when is the next t-shirt giveaway? 2 of them coming soon because one is when you finish your exams and then one for Christmas one. I don't know, I was thinking about making like a Christmas Infinity Plus One t-shirt just for the hell of it. You know? Get some green and red and whatnot. You're welcome, Stacy. I think it just kind of dawned on me, Stacy, is like I got you for another couple of days and I say bye-bye to you. Yes, Kevin, we'll be doing one more on Sunday night. But mainly excellence questions, right? Like funny story, Adrian, I applied a couple of times, it got rejected. I love it, Vader. I don't think, no complaints there. I think that's part of the reason why I can do this. You know, I think I enjoy my time there. That's crazy, Scott. Jameson, yeah, like I'll pick up the question tomorrow and see. I was actually trying to do. I might actually do a speed run for the hell of it, rather than trying to do a explanation video. Because I mean, I do obviously I do the explanation video much later when the answer schedule comes, but try and do a speed run of the paper just to see how fast it can be done. Oh, Rice, I love that idea. Ugly Christmas Infinity Plus One sweater. Yes. Have a good night, man. Adrian, I've done my time. I've done my time at OSC. I did 7 years. I think that's more than enough. But the thing is, it's like, you know, if there's anything, it's like love. I don't know. I don't know. I've got a lot more work to do at OJC at the moment. Who's your brother, Vader? Because I'm going on that road trip. That'd be awesome, Stacey. Tell all the 11s to stop stressing. Lex, I'm going to be done in like a couple of minutes, just having a bit of a chat. Oh, you and Ross Pingu. Oh yeah, nah, I worked with that boy a couple of years ago with he made some t-shirts and some vinyl work. Lex, it'll get saved so you can watch from the beginning. No worries, Scott, you're welcome. Accurate. Yes, Jenny, you can do that. But I would be careful. Like, look, Jenny, I would actually say, like, if you see a proof question, and if you get the proof question correct, you know you're gonna get the 8 points. So I always go and read the paper first and see where's the proof questions, and then try and do the proof ones first, because then I can actually skip the other questions. Seriously, you guys speaking like a foreign language when you start talking about chemistry. It's like, even though I did it in year 13. I can't remember everything. Scooby-Doo, that's strange. That's hilarious, but strange in a way. It's almost like Mufasa from Lion King, like, remember, y equals mx plus c. Seriously, the dog is thirsty like anything. He's gonna finish all the water too. You know, for a little dog, he drinks so much water. What's my least favorite subject? English. Oh, he's gonna go out for a buck. Oh man, come on, don't go out for a buck. Please don't. What's it? No, he's gone out. He's gone out for a buck. Bus not, just give him like about a minute. He'll come back and then I'll show you guys. Oh, did you do differentiation last year? Didn't hear. He's gonna go buck. I can feel it. No, he's not. So yeah. So anyway, guys, look. I think I might actually go get some shut eye. I don't think the dog's gonna come back. But ugly sweater idea. Ugly sweater idea. Let me have a look. Ugly sweater jumpers. Oh my god. These are terrible, these jumpers. But more importantly, why would people wear ugly sweaters in New Zealand? Because it's like summertime, right? Oh, William, Social Blade predicted me to go to 100k in November. I don't think that's happening because this is when my subs start dropping. I lose about 1,000 subs from now till January. It disappears, William. Ugly t-shirts. Okay, well, we can have a look at ugly t-shirts. I'm sure it'll reach. Like, look, RX, I'm not really, I think when I do these things, I don't really care about that. I just kind of let it go. And yeah, 1 million of subs in 2027, which is a bit weird because it's like, I don't know how it's making that prediction because it's the most ridiculous time series prediction. Why do people unsubscribe? Because they don't want to hear, like they finish, they go to uni and then they're like, oh, I don't want to be listening to this guy again. So it's time to let it go. But my suggestion is, like, if you are, don't unsubscribe, just click off all the notifications from me, but stay subscribed. But it always happens every year. It's like I lose like a good here comes the boss. Where is he? Hey, what's it? Come here. What's it? Good lad. Come on. Okay. Here, come here. No, where are you going? There you go. You wanna look up? I'm here. This is the first time you're looking at yourself. He's getting old now. Hey, old fella. Okay, turn around. Okay, don't pull my t-shirt. There. He's a good boy. Right. I'm gonna let this one go. Wait. I'll let you go. Hold on. There you go, buddy. Good lad. Alright, guys. Look, I think that's enough for me. Have a good night's sleep. I will see you guys on Sunday night for sure. I'll let you know about Saturday night, whether I'm going to jump on or not. I might do a speed run of these papers just for the hell of it later, but have a good night and keep revising, and good luck. If I don't see you on Sunday, have a good exam on Monday. That's when you guys are. Yeah, I'll try and do a speed run of it. I probably won't. I don't think I'll have time to explain it like I normally do, because I probably want to do that with the exam papers next year. But I'll do a speed run of it so I can just kind of watch it real quickly and then have a go through it. All right. Cool. Thank you guys. Have a good night, and I'll see you. Yeah, I'll see you Sunday night. All right. Take care. Bye.